can start the class today. So, so this is the schedule for this coming 2 weeks because we are almost done with school here. So, just let you guys know that. So we'll fin. Today's is Thursday, July 18. We will be doing 9.2. So next week we will be doing 9.3, 10.1, and 10.2. Monday, Tuesday, Wednesday, and then on next Wednesday, the 24th, your online homework 82839192 is due. So there are 4 homeworks due on next Wednesday. So I would highly recommend you guys to start working on your chapter 8 and 9 homework. Don't wait. You don't have a lot of homework left. And then so that will be the next week. And then the following week, which is July 29th, that is a pre-test for this case, pre-test finals in this case. And then you have 2 study days in after that on Tuesday and Wednesday. So the pre-test finals that is on Monday, July 29th is on Zoom. I highly recommend you guys to come because this is where this, as you guys familiar with the pre-test midterm that we did like 2 weeks ago. So this is a pre-test of the final. So this is also highly recommend you guys to attend. And also I highly recommend you guys to rewatch this video. There are 2 study days on that last weekend there, Tuesday, July 30th and Wednesday, July 31st. Then on Wednesday, July 31st, your online homework due will be the last 3 sections, 9, 3, 10, 1, and 10, 2. And then on Thursday, August 1st, you will have your finals. It's from 10 to noon, 2 hours in CBT 160. It only covers chapters 7, 8, and 9. 10, 7, 8, 9, and 10, sorry. 4 chapters here. The format is kind of similar to your midterm. You got like 5 open-ended questions, 5, 6 open-ended questions, and you got like 10-ish multiple choice, like what you guys did in midterm. Okay, but this time the covering chapter 7, 8, 9, 10. So we do not cover the first 6 chapters in the midterm. So that will be your finals. If you cannot come on these finals on August 1st, Thursday, August 1st, please let me know as soon as you can because I will be gone on August 2nd. So just want to tell you that. So so that means that if you contact me a bit later on, you might not be able to take the finals. That's the other thing. So make sure you guys, you got 2 weeks from now. So if you know you'll be gone or you're not able to attend these finals, you can take it on the 30th, you can take it on the 31st, but you have to take it in the testing center. That's the thing is, okay, you can take it early, you just need to let me know. So I know some of you mentioned anything. I think 1 or 2 students did mention about taking the test, the finals earlier. If you do, let me know. I highly recommend you to take it either 30th or 31st, right after the pre-test final. Because then you know what is kind of like your finals looks like. So I would recommend you to take it either 30th or 31st. Anyone have any questions with the schedule that we have for the last 2 weeks here? I'm going to start my video. Okay, if you have any questions, do send me emails or talk to me after class on my office hours, especially if you want to take your finals earlier. That will be something that I will highly recommend you do. Talk to me. Okay. So today's class is going over 9.2. So yesterday's we did 9.1. Yes, it is a lot of work. I didn't say that this is easy chapters. I mentioned already in the beginning of class. This class is slowly getting more difficult, and we are on the peak right now. So that means this is kind of like the most difficult few chapters, few sections left. Yeah, chapter 9 is actually the most difficult one. So we did in chapter 9 we do what we call as 2 groups or 2 samples or 2. We break the population into 2 different groups. And we want to figure out if these two groups are having the same, or are they one group is better than the other one, or one group is doing not better than the other or less than that. Okay, so that is what we're doing so far in 9.1. We do concentrate on the two population proportion, where everything we did in 9.1 here is about categorical variables, like either you wear seatbelts or not wear seatbelts, or either this is talking about either you get the vaccine, either you got a vaccine or not, a placebo. So those are the one that you will get as a proportion here, and you don't see the word mean in the question. You always see usually they'll give you a lots of bunch of statistics like your N, your X. Okay, so make sure you know what X and N stands for in this case. On top of it, you are also required to do two types of inferences here. One is performing the hypothesis testing, and the other one is performing the confidence interval. So, so this is for the two population proportion. So we will be continue doing today's class in 9.2 is for the two population mean. This is independent samples. So how do we know that this is this is coming up from the two population mean? In this case is one. Make sure you know that this is for quantitative variable. What do you mean by quantitative variables in this case? Quantitative variable in this case means that it is like your height, your weight, your test score. Those are the quantitative variables. So that means usually it has units. Okay. So last time when you look at what you have before in the proportion case, you don't have any units. This one you have units like kilograms, inches, those are the units that we're talking about. And for this 9.2, when you do the two population mean, we actually have two types. Either the two, since you break into two groups, either the two groups that you break in are independent, or either the two groups that you break in are dependent. Okay, so that means the two samples that you make are either independent. Now, what is the meaning when I say that these two samples are independent? Means that one population or one group does not related or somewhat pair or match with the other groups. Okay, so that means that let's say if you break this into like what we just did last time, those who given a vaccine and given a placebo. So you can only be independent. Independent in this case means you only belongs to one of this group, means that the other group does not related to, that means you cannot be both groups. Okay, so this is what we call as independence. So if you have such case, if you find out that this is an independent samples with the mean, we are doing 9.2. Okay. What happens when your two groups that you break in this case are dependent or matched pair? So this is the meaning of what you call is dependent or matched pair. Means you break this into two groups. In order for it to match pair, that means that these two groups have somewhat inherited relationship. Now, what is the meaning when I say inherited relationship? Inherited relationship is like husbands and wives. It's like brothers and sister, like father and son, mother and daughter. Those are what we call as inherited relationship. That means that you are trying to figure out this like husband and wife, who is smarter, or your brother, your sister, who is taller or who is smarter, who earns the most money. Those are the stuff, right, that you like to compare, right? See who is, but make sure it's means quantitative variables. So if you want to compare those between your sister or your brother or your wife or your husband, all those things, as long as you have what we call as inherited relationship, that is what we call as a dependent or a matched pair. So if you have such, if you want to do an inference statistics on those kind, then it has to be on 9.3. Now, and also, beside the inherited relationship, it can also be this case where one pair, that means same subject is given two measurements. This is another way. So there are two ways for us to do it. You call it before after. So another thing that beside inherited relationship we consider dependent is also what we call as if one person or one subject, one person is given us two measurements, and usually the measurement is before and after a certain thing, like your weight loss or your, or your test score, because it doesn't so anything that is done means you this person is giving you a measurement before something happens, like a diet or a tutoring or whatever it is, and then after that you do it after. Okay, so this, if you have such case, then this is what we call as a dependent match pair. Another case that I say is a dependent and match pair in this case, if you are comparing the same thing in different years. Okay, so if you have this, it also belongs to the match pair case. Okay, so this is also belongs to the dependent case. Okay, so what do I mean by comparing the same thing different years? For example, is like COVID-19 death. So if you want to compare the COVID-19 death between the first year, which is 2021, and let's say this year, 2024. So if you're comparing 2 years, only two, in two, not more than two, because we're doing 2 years. 2 different years in this case, then we have to treat it as a dependent case. So anything that you want to compare in between, like maybe gas price or temperature or whatever you want to compare, as long as you're comparing it in 2 different years, 1 year is this 2000 whatever year, and then this year 2024. So if you're comparing 2 years, then it is also considered a dependent match pair samples. So if you have such case, inherited relationships data, you got data that is coming from the same people before and after, like weight loss or test score or something else that is before and after, or you're trying to comparing things that are from 2 different years, in the same thing, but 2 different years. Then this is all treated as a dependent samples in this case. Okay, so make sure you guys do understand this, because this is where a lot of students make mistakes in the finals, because yes, this is coming up in your finals, and a lot of students, let's say that we are doing husband and wife information, and the students think that they will treat it as independent, and they did 9.2, and guess what? I can tell once you did 9.2, I know you did the wrong test or the wrong case in this case. So I can tell you the whole thing is wrong, but I won't give you 0 because you did the work. I know it's a wrong test, but you still earn quite a few points. But I think I will take like a point or 2, depends on how serious the damage is. So so if not that too much, then maybe I'll take 1 point is the least I can take in this case. So I will say that so make sure you guys know the difference between these two. So that is very, very important in this case. Okay, so so let's talk about the first 2 examples, because this is the first 2 examples that they will ask you here. So which of the following examples involve independent samples? So question 1 or question 2. So to test the effectiveness of Atkins diets, 36 randomly selected subjects are weighed before the diet, and then 6 months after the treatments with the diets. So they will do so that means that this is doing your weight will be measured before and after the treatment, and the 2 samples consist of before and after weights. So this kind of questions is considered independent or a dependent samples. Anyone?
Dependent.
Yes, this is a dependent samples. So that means that if you have this, because we are using before after measurements, so if this is coming up in your test, make sure you refer to 9.3, which is next Monday's class. So do not do 9.2, which is today's class. Otherwise, you will get not a full points. Okay. Question number 2, again, asking for is this an independent or dependent match pair samples? Annual incomes are obtained from a random sample of 1,200 residents of Alaska, and another random sample came from 1,200 residents in Hawaii. So you got 2, 1 from Alaska and 1 from Hawaii, 2 groups. So is this independent or is this a dependent sample? Anyone?
Independent.
So this is an independent sample because if you're a resident in Alaska, you cannot be residents in Hawaii. I think you only belongs to one resident in this case, right? You cannot have a two residency in two residents in two different states, right? So you can either only belongs to this one group. So this is independent sample is because you can only belongs to one resident per state. So except for maybe Florida, you can able to have two, but I think Hawaii and Alaska you can only be one per each. So so in this case that this if you got this data about this or you got this information, then make sure that you will need to use 9.2, which is this coming section you'll learn today's class. You guys clear with this? What we're trying to do here. If you find out that this is talking about weight and this is talking about income, so these are quantitative variables. So that's why we don't do proportion here. Proportion is for categorical. So this is quantitative. So that's why this is doing about the mean in this case. Okay. So so let me show you what is the StatCrunch syntax so you guys know. So we go back up here and we'll talk about notations and so on. So for the StatCrunch syntax, so we are doing 16 today. So again, we are doing both confidence interval and hypothesis testing for two population means that are independent. So how do we do this is t-stats, two samples, either with data or with summary, depending on the questions we have. Okay, so last time we did one sample, t-stat one sample, but this time is t-stats two sample. When we do one population mean is one sample with two population, two samples, and then you pick data or summary depending on the questions here. And you got the options here because if you are doing hypothesis testings, make sure your option is for the hypothesis testing. If you're finding confidence interval, then the options is for the confidence interval. Okay, so let me show it to you in StatCrunch here. Where was it at? So you guys kind of know, where is the location at. So it's very similar to what you did in one sample. So stats, t-stats, two sample, either data or summary. And how do we know it's data? Is the question provide us the data set, or they ask you to key in the data and then you use it there. If you want to do with summary, then it will be the question gives you the summary statistics, the sample mean, sample selection, and sample size. And then again, this is what I'm talking about here. Just you got two options here. Hypothesis testing for this and confidence interval. So we usually do not check on the pool variances here. I will tell you what's going on that case. So you will so this is what happens when you do this 9.2, having what we call as two sample T summary in what we call as StatCrunch. But if you want to do the data one, you will see two sample T data. Okay, just want to tell you that so you guys know the difference between so you will see oh, yeah, just two sample T. Yep. So that means they will put the data here. And again, you got the choices of doing either confidence interval or hypothesis testing. And again, I mentioned early on, you can only, although the question asks you to do both, StatCrunch cannot do both of this. They can either do A, hypothesis testing, or B, confidence interval. So if you want to do both, you have to do A first, one of them, and then go back and do the other one. So I don't think so there's any statistical software right now that can do both hypothesis testing and confidence interval in one shot. Okay. We have, we'll tell you more about those. Okay. Once you go to the higher level in this case. Okay, so let's do some notations in this case. Does anyone have any questions to distinguish between the independent and dependent samples here? All right, so here comes the notations here. So again, you see the subscript ones, and then you see the subscript of 2. So if you see 1 means it belongs to the first group, 2 belongs to the second group. And as usual, as I mentioned early on in 9.1, make sure you identifying which one is population 1 and which one is population 2. And I think I told you already about the rule of thumb that the first variable that comes in will belong to the population 1. Okay. So this is the rule of thumb that we always do in the world of statistics, right? Like what we did last time. If the vaccine data come first, vaccine will be population 1, the placebo comes next, that will be the second population. Except for your online homework that I mentioned early on, your online homework did tell you which is the first and which is the second. You have to follow that, otherwise you get the wrong answers. And I did, yesterday we did what happens when you switch your population around, something is changed. If you remember what we did last time when we switched the population around, you find out that your p-value remains the same, but your test statistic is being swapped, right? From negative to positive or positive to negative. Also, your confidence interval will be different because your upper limits will become your lower limits. Your lower limits will become the upper limits if you swap your population around, and also your sign will switch from negative to positive, positive to negative. So that is what is going on here, and that's why your online homework can't detect it because they only detect one answer. So so that's the reason why they will tell you which is the first and which is second population. However, in your finals, you can do which is which, but make sure you tell me which one is the first and which one is the second one. Okay, this is quite important here. So same thing happens in the mean. We'll do the same thing here. Okay, so mu1 in this case, it stands for population mean for the first group. Sigma 1 in this case is the population standard deviation for the first group. Okay. N1 is the sample size for the first group. X1 in this case is sample standard sample mean for the first group. And the last one is S1 is the sample standard deviation for the first group. So these are all what we have to do here in 2 means. There are independent samples. And then once you replace the 1, 2 with 2, then it will go to the second group. So these are the notations we'll be using quite a few. Requirements. The first requirement that you see here is what we call as the value of sigma 1 and sigma 2 are unknown, and we do not assume they are equal. So this, I will point out that you do not need to check this requirement. Okay, although I put in there, this is always assumed is met. Okay, so this requirement that I just draw a thick line underneath it, we always assume that this is met. So another meaning is that you do not need to check this requirement. Okay, so I put a little cross on it so you guys at least can see it instead of so I just put a little X here. So so that means that in your finals, you do not need to check this requirement. So that is assumed that it is met. Okay. And here is a few that I will point out. Make sure that both samples come from SRS, CLT. Oh, guess what happens? This is exactly the same as what we did last time for the one group, okay, requirement. SRS, CLT. And what CLT means the population is standard normally distributed, or the sample size is more than 30. So that is the meaning of this CLT here. But this time we're not doing one, we're doing both. So make sure that both of these samples or populations have these rules. What happens if one sample have more than 30 and the other one is less than 30? Then the other one is have to check the robust case. Okay, so this is for the smaller sample size, robust case. make sure you check for symmetrical, you check for one mode, and check for no outliers. We could talk about this before in the mean, one mean. Guess what? It is the same as what we did in here, two means. The only different about this is here. This has to be independent. So make sure you guys know that, because the two samples here has to be independent. Because if it's an independent, then you're doing 9.2. If you found out that this is not a dependent or match pair, please move on to the next section, because you will get wrong testing in this case. Okay, so make sure you understand this, very important. Stack crunch, we mentioned about a stack crunch is you go stat, t-stat, two samples with either data or with summary, depending on what questions is provided to us. Okay. So next one is the 7 steps of hypothesis testing in this case. So again, you can do hypothesis testing and you can do confidence interval. So again, if a question asks for hypothesis testing, you have to perform the 7 steps. Mostly the 7 steps are exactly the same 7 steps that you guys been doing so far. I did not change the table. Everything is the same. The only different in this case is that the requirements are a little bit different here. The next one is the statement. So for the second step, when you do your hypothesis statements, you will pick either doing this, mu1 equals to mu2 for your now. Alternative is mu1 is less than, greater than, not equals to mu2. Again, how do you know which one is you pick the less than, greater than, not equals to? It's in the claim statement, so you have to read the claim statement carefully. You can also write your claim statement, your hypothesis statements as mu1 minus mu2 equals to 0, or mu1 minus mu2 less than, greater than, not equals to 0 for the alternative hypothesis. This is the stack, the one I highlight in blue is what the stack crunch is used. This statement is very similar to the statement we just did in proportion in 9.1. The only difference here is we don't use P1 and P2 because that means for proportion. We use mu1 and mu2, which stands for the mean. Okay. The next thing about this is for the mean here is your sampling distribution. Your sampling distribution in this case, we will use a T distribution. So make sure you understand that we are not using Z. Z only used for proportion case. And I do not want you guys to look at the formula. So that is how you find the test statistics. If you don't have stack crunch, I'll be happy. Please use that formula. Please, this is very, very special here. It's very difficult formulas. Again, as I mentioned, once you get more difficult, the formulas is going to get more tough. But your stack crunch will give you the test statistics and your p-value without any formulas or using tables or anything. Just want to point out. And if someone that you tutor or you watch videos or you find it's try to do your homework and ask me to help this, if they use formulas or tables like this, please ignore it, okay? Because you will even get more difficult, and I'm not teaching you the difficult way, because this formula, if you look at this formula, it will take you around like 1 page to figure it out easily, okay? So please don't do that, okay? Now, the degree of freedom, if you recall last time for the T distribution, the degree of freedom is n-1. Okay, this is the degree of n-1 for one sample. Okay, however, this is a 2 samples. Your degree of freedom in this case is not n-1. The degree of freedom is very difficult to find. Actually, the formula is even worse than the formula you see that I crossed it out here. So, but your stack crunch do provide you the degree of freedom. So for the degree of freedom in this case, please check stack crunch for it. It's not n-1. I also doesn't know what is the formula for degree of freedom. I saw it one time and it's not, I'm not gonna bring it out because it's gonna be something worse than the one that I just crossed out. Okay, so again, this is the hypothesis testing 7 steps procedure here. The next one that I will also call you to do beside hypothesis testing is the confidence. Sorry about that, class. I think there is a bit of disconnections there in class just now. I think that's why it's, so I'm gonna go back to continuing where we stopped here. Sorry about that. I think my internet was a bit off today. Let me see. You guys hearing me, seeing it okay? Anyone thumbs up? You guys good?
Yeah.
Yeah. So I think we stop at the degree of freedom. I think it's just a glitch, like a second or 2 seconds glitch just now. So we're gonna follow. So that is the first thing you do, and then we'll also ask for confidence interval. So this is around 3 to 4 steps. I mentioned about the 4 steps yesterday. So it can be the 4 step in this case. Mostly it's 3 steps. The 4 step in this case is to interpret the confidence interval. So the 4 step can be used if the question asks you to interpret. If a question did not ask us to interpret, then you only do 3 steps. And as usual, this is exactly the step that we just did in the proportion in this case. First step is in this case is to figure out what is the confidence level is. Second step is using StatCrunch to find the confidence interval. Okay, one's level and that interval. 3 is to make a conclusion. Okay, for the confidence interval, and then I just mentioned again, the conclusion that you guys did here is the same as the hypothesis testing. And then the 4th step, which is in this case the optional step, is to interpret the confidence interval. So this is optional. When I say optional, means that it's been asked by the question. I say optional. If the question is, there you go. So if a question asks you, then please do that. If a question do not ask, 3 steps. Okay. The confidence level that we did is exactly the same confidence level we talked before. Remember the confidence level for 2 population proportion we did yesterday. So in order for us to figure out confidence level, you have to figure out, are we doing left or right tail, or are we doing 2 tail? If you're doing left or right tail, the confidence level is given for the formula of 1 minus 2 alpha. If it's a 2 tail, it's going to be 1 minus alpha. So this is used quite a bit. So this is the one that you will see it right over here. So when you have to find the confidence level, if it's a left or right tail, it's 1 minus 2 alpha. If it's a 2 tail test, it is 1 minus alpha. This is actually copy and paste from the previous section. So this is your first step, where you find your confidence level here. Okay, step number 1. Step number 2 is to write your to figure out your confidence level. So step number 2 in this case is to do your confidence level. You use StatCrunch to do this, okay? But again, there are few ways for you to write the confidence level. The most basic way is to give me the lower and upper. This is the most basic way to give me the confidence level. However, if you want to write this in the lower and upper in the form of inequalities in this case, so you make sure you use this as mu1 minus mu2. And then, so this will be your lower goals and this is your upper goals. Okay. And again, we don't use this formula to find the margin of error. Again, the margin of error is found using the same formula we did so far, which is upper minus lower divided by 2. Okay, which is the same margin of error that we've been using so far. Upper minus lower divided by 2 in parentheses, make sure you parentheses are now around them. So this is the same formula we've been using so far. So again, we're not using these complicated formulas here. That's the reason why this class I try my best to not give you difficult formulas to memorize. Okay, and then that's your second step. Finding confidence confidence interval using your StatCrunch. And then the third one is to draw conclusion. Okay, and the conclusion is exactly the same conclusion we did in proportion, the 2 proportion that we did. So in order for us to draw the conclusion for confidence interval, you look at the values. If both of these are negative, means it does not include 0, then you will use mu1 less than mu2, or mu1 is not equal to mu2. Again, which one do you pick between these two is refer to your H1, your alternative hypothesis. That's where you will pick one of this. Then the second one is if both of these confidence value is positive, means it does not include 0, then you will say that mu1 is more than mu2, or mu1 not equals to mu2. Again, which one you pick, this is you refer to H1 again. And the final one for the confidence in the conclusion in this case is if you have one negative and one positive, it means that this is including 0. That means mu1 equals to mu2. So if you look at this confidence interval conclusion and the confidence interval for the proportion, they are exactly the same. Okay. The only difference is instead of using P1 and P2, we replace it with mu1 and mu2. So that is not much different as you guys can, compare between those two. So that's why if you know how to do 9.1, you should know how to do 9.2 and 9.3. It's just the same thing, but it's just changing a little bit of notation in this case. Okay. And then the last thing we're going to do here, the fourth step, which is the one that optional or been asking the question, is to interpret your confidence interval. So in order for us to interpret your confidence interval, this is the same interpretation we've been doing so far. Remember, I draw a purple box and then I put a few stars on it. So I'm going to do the same before I draw the box. I will highlight. It's going to be the same here. We are 95, 99% confidence. This is from lower to upper class limits here. Contains the true value of the difference between two population means of the context. So what you need to fill out, now I can draw the box here. So this is the same interpretation that we've been using so far. Okay. So where you put the 95 or 99% here, this is where you put your lower and upper for your confidence interval here. And this is your context. This is talking about male or female or some, your context. Usually you can find that in the question. So what is the confidence interval interpretation difference between this one and 9.1? This word. Okay, so if you look at this, they are all exactly the same, except that this we are doing two population means. If you look at 9.1, it is two population proportions. Okay, it's all the same except proportions. So you kind of know that David is a bit lazy to type 9.2 out. He just simply copy the whole 9.1 and paste it to 9.2 and change anything that has a word proportions or p's into mean, mu. That's what I did actually, to be honest to you. Okay, so literally I just copy and paste them. Okay, so that is the only difference between this. So make sure you guys know that these are the 4 steps for confidence interval here. And the quotient is the same quotient that we've been talking about here. We don't do overlapping in this case. If you have 2, you don't do separate thing. You don't do 2 individual confidence interval. I explained that yesterday. The reason why we don't do this is because the confidence level is decreasing. Because if you do this is 0.95 to the power of 2. Remember last time I do a 95%, and this is around 90%, right? Around 90, something like that. So so that means that if you want to do separate, if you want to do 2 individuals instead of 2, so what we do here is we do these 2 groups together. We compare it together at one time. But last time in chapter 7, we do one for the male and one for the female, and then we figure out if they overlap or no overlap, something like that. But if you do such thing, your confidence level will decrease from 95% to 90%, because when you square it, it becomes 90% in this case. Okay. And then we also talk about what happens if you switch your population around, right? This is also the same thing. If you switch your population around, your lower will become your upper, and your upper will become your lower in this case. It's the same features. for this case, for the population mean. The only difference here is we don't use P, we use mu. So this is the only difference in this case. So nothing new in this case, right? Kind of like same as what we talked about it before. So so as you guys know that we almost done the class. So some of you will ask me, David, what happens if I have 3 samples and 4 samples? Because remember this one, we break this into 2 groups, right? So what happens if you break this into 3 or 4 or 5 groups? That one will be your next statistics class. So yes, when you go on to your next statistics class, you'll be doing what happens when you will break more than 2 groups in this case. Yes, that will be a different distribution. You're no longer using Z or T distribution like what we just did in this section or last section. You will use a different distribution in this case. So those are for more than 2 groups. Okay. Anyone have any questions so far with 9.2 before we start the examples here? So very similar to 9.1. Okay. So let's take a look at question number 3 here. Question number 3 is asking us that in the height of men and women are used to construct a 95% confidence interval, where the difference between the 2 population means result this. This is the answer. This is the 95% confidence interval, where the first population group is men, and the second population group in this case is women. Okay. So this question is asking us, right, what does the confidence interval suggest about the men and the women in this case? So if they ask you about these suggestions, means they want you to do step number 3, the conclusion. Okay, I know some of you was like, David, it doesn't say conclusion. This is what I will tell you here in your homework or in your test. If I ask you what is a confidence interval suggest, means I want conclusion. If I want interpretation, then I will ask you to interpret. So this will be step number 4, where you have to interpret. So make sure you read the question really carefully what they want. And some students think A is interpretation, B is conclusion. And this kind of questions is coming up in your final as the multiple choice question, because in the multiple choice question, question 1, I give you this. Question 1, what's the confidence interval suggest? A, B, C, D, E. You think the interpretation via 95% confidence will be there? Definitely will be there. Okay. But I do not want that, because when I ask you for this, I ask for the conclusion, which is the meaning of are they both negative, both positive, or one negative, one positive. That is the conclusion I want. And then in question 2, I will ask you in the finals and multiple choice question, it'll be like, how do you interpret this? And make sure when you interpret, you don't look at negative or positive values. You're looking at this via 95% confidence interval. So make sure you guys know the difference between what the questions what I'm asking for, and do not swap them around. And then question C is asking us is what happens to the confidence interval if you switch the population around. It means now the women is the first group and the men are the second group. Okay. So so this question 3 is definitely going to be coming up in your MCQ in your final. So please pay close attention here. So in question A, we are doing conclusion here. So conclusion in this case is depending on the confidence interval values. Are they both negative? Are they both positive, or one negative and one positive? Since these 2 are positive numbers, so the lower and upper both are positive numbers. So if they are both positive numbers, then mu1 in this case is greater than mu2. Okay, or mu1 not equals to mu2. But we do not have h1 because this question does not give us h1. So we just pick those 2 conclusions here in this case. Okay, since there you go. Since both the values are positive, it does not capture 0. Only time that you capture 0 is one negative and one positive. We conclude mu1 is greater than mu2. Again, I don't have the symbol mu in my keyboard. Or mu1 is not equal to mu2. So this is depending on each one. So this is how we draw your conclusion on question A in this case. Okay. So that is how we do question A. Anyone have any questions for me? Right. Question B is that interpretation. So in how you write interpretation, we are 95% confident that the interval from the lower, in this case, is 11.61 centimeter to 17.32 centimeter. Capture the true value of, now we're going to look for back, the difference between the two population mean. Okay. The true value of the difference between two population mean height of men and women. So this is your context. The height, mean height in this, the population mean height of men and women, because we are doing two groups here. And the reason why you need to put men first is because population one is men. Just I don't want you guys to do women first because this question asks for men as a first population. So sorry for that, women's in the classroom here. I cannot. Depends on the questions, right? I cannot. So make sure you follow what the question wants to do. C. In this case, C is asking us that what happens if you switch your population? What happens if you switch your population around? What is the confidence interval? So what do you do, class? Is your upper limit, which is 17.32, will become the lower limit, so become negative. Change your sign, and your lower limit will become your upper limit, and you switch your sign too. And then you will switch around. This is the women and this is the men. Okay, so this is what happens when you switch your population around. I think you guys are familiar with that. We did this before in the portion one. It also happens the same for the mean. Questions on question number 3, which is you will see this in the MCQ for ABC here. Oh yeah, definitely will see this in MCQ. Anyone? Any questions? All right, so question 4 and question 5 is where you begin to do some hypothesizing of confidence interval. So this question mentioned that for question 4 and 5, assume sigma 1 and sigma 2 are unknown, and we assume that they are all equal. So this is usually telling us that the first requirement for the population, for this case, is math. So you do not need to check it. Okay, so we just need to check the other 3 or 2 in this case, then the independent is the one. So so we're going to check those. So question number 4 is where you will refer to data set 14 word counts, where the measure word counts for men, we're using M2 for this case, and also the measure word counts of women, F2 in this case. Use a 0.05 significant level to test a claim. Here's a claim here that men talk less than women. So we doesn't know that, right? Sometimes some people always think that men usually is a shy one. They talk less than women. I do not know. So we try to prove it. And then it say beside the word counts, what are the factors or variables will affect your conclusion? So you're going to give me that effect, what is going on here. This question, you have to do your check the requirements and so on and so on. Now, if you read this question, kind of like glance through it, are we doing hypothesis testing? Or are we doing confidence interval? Or are we doing both? For question 4. So this question is just doing what? This question is just performing a hypothesis testing because you got all this requirement now, alternative, and so on. So that means that if this question come out in your test, you do not need to perform the confidence interval. If you do it, no extra credit points, okay? So make sure you know, sometimes I ask for hypothesis testing, sometimes I ask for confidence interval, and sometimes I ask for both. It's very easy. Usually if I ask for more than both, then I will say that what happens here, but then you will have ABC like that. So once you see me putting ABC part like this, then I will say that you will get it for both in this case. Okay, so this one you're gonna do both. So you can, I don't even read the questions. I can tell already that because this is, this is testing the claim and this is using a confidence interval. So I can tell that once you see, same thing happens in your finals. So once you see the ABC come out, I mean, read the question again, but I will just have a mindset saying that, oh yeah, this is going to be used. You're going to do a bit more work here. And another thing is you look at the points. If I give you a lot of points, that means you have to do both of this. But if I give you 10, like say this is like 12, 11 points here. Usually it's just you're doing it just hypothesis testing because confidence interval won't give you that much. Okay. We do straight to the sampling distribution first before we even start doing it. The sampling distribution is a T distribution, so make sure you guys know this. This is step number 3. Those who are wondering what kind of step we are doing on this case, sampling distribution is always step number 3, and we're using T is because of it is a mean in this case, not proportion. Okay, Z will be the proportion. So yes, let's check the requirement here. First step is independent. That is the first, before you even check for SRS. Independence, this one is checked. The reason why this is checked is because that you can only belong to either male or female. You cannot belong to both group. And I know that is a non-binary and binary gender and all this different gender that we have right now. But I want to tell you straight away that in this class, unfortunately, we're only doing 2 men and women due to the binomial case in this case. So that's the reason why that we don't talk about other groups. But if you do talk about the other groups, the binary and all those non-binary groups here, then unfortunately we cannot use this section because it's more than 2 groups. Remember, more than 2 groups, you have to take it in the next statistic class. So that's the reason why that we only mention male and female here because this case we'll do 2 groups. Okay. So sorry for that if I offended someone else who are in the other groups in this case. Okay. Okay, so we talk about independence here, so which is good because it only belongs to male or female in this case. The next thing we talk about here is the SRS. SRS, as I mentioned, that all your data set from the textbook is automatically XRS, simple random sample. So that means this is also checked. Okay. And the third one is CLT. So CLT in this case is looking for population is normally distributed, which is not mentioned here that they don't mention the populations are normally distributed. So you cannot assume it, but we can also look for the sample size here. So let's check what happens to the sample size in this case. So I will pull out the data set from the textbook in this case. Where was that? There you go. So data set from textbook. Again, class, this is the only way to get a data set from the textbook. Go to your homework and get it from there. Do not go online and search for it because you won't get into it. We are doing what? Let's see, what is the section? Number 14, right? So we're gonna look at data set number 14 here, which is right here. And there's a lot that M1, F1, M2, F, all these things, but we only concentrate on M2 and F2. Okay. And again, in your finals, if you have no idea which variable you use, just raise your hand or read the question again. It's in the stated question here, and I will tell you which one is. So let's go. M2 is 37 and F2 is 42. So this is how many M2 and F2 we have. Good news is that your N1 is more than 30 and your N2 is more than 30. So this means that this is checked. So this is not a robust case. So good news is both of these is both data set here. It has more than 30 people here. Okay, so that is good. So in this case, that your requirement here will met. You guys good? So you're kind of getting a bit tired of doing hypothesis testing right now. because we've been doing that since last week. And guess what? Next week, we also continue doing this. So the whole chapter 7, 8, 9, 10 in this case are all kind of similar. Okay. So for doing your claims, second step is to write your statement here. Your null hypothesis H0 is mu1 equals to mu2. And if you look at this, oh, I forgot to declare which one is which. So as you can tell that the men come first. So that means that your population one will be men, and your population 2 in this case will be women. Okay, so based on what we have here. So mu1 is equals to mu2 compared to your statement. Your claim statement says that men talk less than women. So talk less means less than mu2. So especially if you declare mu1 is man, 1 is men, 2 is women. So that is your hypothesis statement for now and alternative. Questions, anyone? The third step is the sampling distribution, which we just did it. It's a T distribution. Now we're going to use StatCrunch to figure out your test statistics and p-value. So this question, you use data. So you're going to use a t-stats with 2 samples with data. Okay, let's see. If I can, let me see if I can. Okay, so this is what we do. So in your StatCrunch, you go to stats, t-stats, 2 samples with data. And sample 1, that means which one belongs to the first group, the man. So make sure you do M2, not M1, because the question is asking for M2. Values for sample 2 is in F2. The where is optional. Don't do anything. Don't check on the pool variance. What is pool variance? Pool variance is, now I can tell you, pool variance only used if sigma 1 and sigma 2 are equal. So that means that this condition is no longer exists. So that means that if I tell you that sigma 1 are unknown, and so this is always assumed that way. So that's the reason why that you don't click on this. If you click on this, is where you figure out that this sigma 1 and sigma 2 is equal. So we call that as a pool variance. So just omit it. Do not check on it. We never check on it in our tests. We will never use this in your homework or anywhere. So do not check on this option here. Otherwise, you probably will get it wrong. Mu1 equals to mu2 is your null. Alternative is mu1 is less than mu2. So make sure you use the less than symbol here for this case. Then you can compute. Okay. So that will be, again, you will get this first 2 will be very similar to your second step, the statements here. Again, we will have the sample difference, which is, you can ignore it. Standard error, you can ignore it. This is the degree of freedom. So that's why you find out the degree of freedom is no longer a nice number like 63 or 64. This is all decimals because it's counted using a very weird formula. But the t-stats, which is the test statistics that you see here, is going to be negative 0.132. And your p-value is 0.4477. Okay, so again, how do we know this is the right test is because you see the word letter T on it. There's a lot of T come up here because we are using a T distribution here. And roundings up to you as I mentioned in your test, 2 or 3 decimal place until it is stated in the question. So your online homework, you just need to refer back to your online homework, how many decimal places they want. And then step number 5 is decision. This is the same decision using p-value and alpha. So your p-value in this case is 0.4477. And your alpha in this case is 0.05, I believe, right? And the 0.4477 is greater than alpha. So this number is more than 5%. So if you doesn't know what decision, you can figure this one out. And I think I told you guys before, right? I think on 2 days ago that this page, 8.1 second page, will be provided in your final. So you do not need to memorize this whole page, but you just need to know how and when to apply it. However, you won't see any highlights, you won't see any stars, or you won't see any little table 1, table 2. So that means that another thing is a clean, nice, clean piece of page 2 here. Okay, so that means there's nothing written down here. So so make sure you guys utilize this as much as you can. Okay, so since the p-value that we found out here is greater than alpha, so which is the second decision we will make, so we will fail to reject the null hypothesis. So that will be our decision for question number 4 here. Okay, so we will fail to reject the null hypothesis. And again, I did mention early on, if you do this in your test without putting the word null hypothesis or the symbol H0, you will not get the full point in your test. Okay. And finally is final 6, your conclusion. So your conclusion is depending on the original claim statement, because it has the word less than. So we're gonna use the claim in this case is less. And the decision we're gonna make here is fail to reject the null hypothesis. And this is found by step number 5 that we have here. So now we will be looking at which is the conclusion you pick, 1, 2, 3, 4. So since you use the claim is less than, so that means if you look at this, we will using the right side because the claim in this case is less than. And if you look at the conclusion decision that we make is fail to reject the null. So that means that we are using conclusion number 2 in this case, where it says there is not sufficient evidence to support the claim. Okay, so this is your conclusion that you have to write for this question here. So we will be doing conclusion number 2. There is not sufficient evidence to support the claim that men talk less than women. So what we found out here, class, is that men actually does not talk less than women in this case. Okay, because we said it is not. Okay. But does it mean that men talk more than women? No, because although we just proved men that talk less than women, we haven't proved men talk more than women. Because if you want to do that, you have to perform these 7 steps again, because your statement is your claim statement is a little bit different now. So doesn't mean talk less is if this is not talk less, then it has to be talk more. No, it is not gonna be happen in this case. Okay, yep, it's fine. So this is the sixth step, and we're gonna do the last step in this case, which is the question. The question is in this case is asking for what other factors or variables will affect this conclusion, which is right over here. So can someone tell me what other factors will be affecting that men does not talk less than women, beside how many word counts that they use?
Personality.
The personality, yes, this is a big one. Because if someone can be introvert or extrovert, I don't know which one. I think extrovert is the one that talks a lot, and introvert is talk less, something like that. You guys know, right? Introvert, extrovert. So so someone, you know, if personality is might be a big issue here. Another one is jobs, your occupations. So I'm a teacher, so I have to talk a lot. Okay, if you're a salesperson, you have to talk a lot, right? So there are quite other variables that you can, or factors that you can put in here. Personality, jobs. Anyone have another variables or factors that you might?
Amount of friends.
Okay, good. Yes. So you can look at friends, how many friends you have, number of friends. So again, if I ask this in your finals, I just need 1. Okay, responsible. What do you mean by that, Korean responsibilities? What do you mean by responsibility, Korean? Okay, while we wait for Corinne, I will take attendance here. Okay. Yep. So again, class, for me is you just need 1 factors. If you can give me the social, yep, occupations, jobs, yep, that will be kind of jobs that you do here. So you know, depends on, that's a lot of, I mean, if you can give me 1, I just need 1 in your finals. Questions, anyone with this question before we move on to the last question today? All right. Last one, question 5. This is where we talk about the weight of quarters. So you notice that these are all quantitative variables. You know, we talk about the height, we talk about how many word counts, we talk about the weight of a quarter. So these are all quantitative. And you probably will see the word mean next to it. This one doesn't have a mean on it. This will have a mean on it. Yeah, this one has a mean on it. So you kind of so the mean on it, this is the mean, and then I think this one should have a mean on it. Yep, this also have a mean on it. So I will try my best to put the word mean on it so that you can tell that this is mean. In this case, it doesn't have the word mean on it. But the other thing you can find out that this is a quantitative variables because it is a word count. So this is talking about weight of the quarters. The weight of 40 randomly selected of pre-1964 quarters has a mean of this and a standard deviation of that. So I'm going to highlight the pre-1964 quarters in yellow. And I'm going to do the other one in purple. For also, we pick 40 random samples of post-1964. One is pre and one is post. It has a mean of this and a standard deviation of that. Now, if you read this purple and the yellow one, this is all for sample because the mean and the standard deviation that you see here comes from the 40 randomly selected, come from a sample in this case. Okay, and you kind of know that which one is the first and which one is second population, since the pre one that comes in, so pre quarters, pre will be the population 1 and population 2 will be your post. So this is kind of like getting the information even before we start doing the analysis in this case. Okay, now we're gonna use some A. We're going to use a 0.05 significant level to test that this is a claim statement that pre-96 quarters have a mean weight that is greater than the 96 post. So that means that pre is greater than the post, and then you have to do all these requirements and so on, so on, so on. So this is hypothesis testing, as you can tell, right? And then the next one we do here is asking to construct a confidence interval in this case. So that means that for the hypothesis, so that means you are doing confidence interval. So that means you have to do both of this. And then the last part is asking you to check what happens if the question in this case. Okay, so we will go through this together here. So we're going to do A, where you have to perform the hypothesis testing. So the first thing we do when you perform a hypothesis testing in this case is to do the requirement check, which is stated right over here. Oh, where was that? There you go. Again, the first requirement check is independent. This is checked for this case because your quarters can either become pre or post 1964. You cannot be both in this case. The second requirement check in this case is SRS. You find out that this is also checked because you have the word randomly selected here, or random sample in this case in both of them. And third, in this case, CLT is also checked because both N1 and N2 is more than 30 because you picked 40 quarters for each one of this. So in this case, your requirements met. Okay. I think I also mentioned before that if your requirement does not met, you still need to continue doing the rest of the hypothesis testing. Otherwise, you only earn 2 points out of how many points. The null hypothesis, the second step is to give me the null and the alternative. So in this case, we're doing mean. So mu1 equals to mu2 for the null, or this equality is for the null. For the alternative, you want to, because your claim statements, which is I highlight in blue here, saying that your pre has to be greater than the post. So greater than, we use greater than. Okay, so make sure you guys use the correct correct statement here. The third one is sampling distribution. This is a T because we are using mean, so that will be a T distribution. The fourth one is the stack crunch. But in this case, when you do the stack crunch, you have to use a summary in this case. The reason why we do summary in this case is because the question gives us summary statistics. So let's go to the summary statistics we have here. So you guys can see what we do here. So you go to stats, T-stats, 2 samples with summary. And this is where you enter your data, your summary statistics here. So the yellow one, the highlighted yellow will be the sample one. So the sample mean is 6.19267. And please do not round this answer to 6.2. You will get it wrong, the mean and everything. So make sure you use whatever they give us in the question. So same thing when you do your homework and your test, do not round anything that is provided in the question here. Otherwise, you get it wrong. Okay. Standard deviation is 0.087 with a 40 random sample for the pre. For the post, I highlight in purple, 5.6393 for the mean, and standard deviation is 0.06194 with also 40 sample size here. And again, do not click on the prove variance. We make it off. Then this is equals to 0, and for the alternative, it is greater than, because the claim asks us to prove for greater than, and you hit compute. So again, this statement that you see here is going to be the same as what we have here. So the test statistics in this case is given us by 32.77 with a p-value of 0. So this is the results you get for this case. Any question for me so far? So we're gonna do decision case. So your decision that we have in this case, your p-value in this found to be 0. Your alpha is given us by 0.055%, and you know that 0 is less than 5%. So that's why we will reject the null hypothesis. Okay, so based on what we did on your decision here, so that will be your decision for this question number 5. Next is conclusion. So the conclusion is also based on your claim, and since my claim is more than or greater, your decision based on step 5, you are rejecting the noun. Okay, so this is the one that you just did over here. You're rejecting the noun in this case. So now we're looking back at the flow chart that we talked about. So since our claim statement is greater than, so this again, we're going to use the right side, and you're rejecting the noun from the decision. So we actually use the first conclusion, and the first conclusion state this: there is sufficient evidence to support the claim. Okay, so that will be the first conclusion we're going to use here. There is sufficient evidence to support the claim. Sometimes they use the word conclude the claim, which is the same. Then you copy the statement here. Oh, it's a long statement here. Pre-1964 quarters have a mean weight that is greater than the mean weight long post 1964 quarters. Okay, and again, some of you will ask me, David, can I short form this? No. Okay, some of you will say, can I just draw an arrow and point out to this blue highlight? You will get 1 point deduction for being lazy in this case. Okay, so please, please, please do not do that. You do need to write it out in this case. So questions in this case, the last step here is we don't have a question here. So you can skip this. Okay, because this question doesn't have a question. The question is actually part C in this case. So that's why. So actually 6 steps in this case. Anyone have any question for me so far with question A, doing hypothesis testing? All right, so the next question B is to construct a confidence interval. So in order for you to construct a confidence interval, you need 3 steps. Since this question did not ask us to interpret the confidence interval, so you do not need to do the 4th step in this case. What is the first step when you do confidence interval? Let's go back, check it out again. The first step is to figure out the confidence level. Is that 1 minus 2 alpha or 1 minus alpha, depending on what kind of test we have. And then use StatCrunch to figure out the confidence interval, and then you draw the conclusion in this case. So these are the 3 steps that I will ask you to do. So let's figure out the confidence level first. So that will be your first thing you do when you do the confidence interval if they don't give you the level. Since if you look at this is a greater than, you are using what we call as a right tail test here. So that means that your confidence level in the right tail test, let me put up my formula here. Level right tail test is 1 minus 2 alpha. That is the formula in this case. So in this case, come on. Oh my God, I'm sorry. This is giving me a hard time. So this is 1 minus 2 alpha. Again, I use A as alpha. Alpha in this case is 0.05 given in the question here, significant level here. So that will be a 90% in this case. So this is the first thing you do here is to figure out what confidence level we use. And 2, you use your StatCrunch to find the 90th percent confidence interval. How do we do this in StatCrunch? Is easy. You just StatCrunch friends here. There you go. So you don't exit off. Go under option and go change to edit. So we are using the same statistic. The only difference here is you just need to click under the perform here and change it to confidence interval, and the level in this case is 90%, and you compute it, and the 90% confidence interval is given us by point, there you go, come on, 0.525 to 0.582, and this is gram. Okay, so this is your second step. Is it gram or gram? Again, you can tell that they all have units here. So that's why, again, I'm not very picky about the units. If you forget the units, it's fine. But the reason why I bring up units is because your mean has units, proportion has no units. Okay. So now we have to draw the conclusion here. So are they both negative? Are they both positive? Or are they one negative, one positive? So since the confidence interval has both positive values, because both of these are positive values, it does not capture 0. And mu1 is more than mu2. The reason why we use mu1 is more than mu2 is because this is what your H1. So as I mentioned that when you see this, when you do the conclusion here, you got, because they're positive, you the mu1 more than mu2 or mu1 not equals to mu2, you have to refer to your now alternative H1 hypothesis. And our H1 in this case is mu1 more than mu2. So that's the reason why that our statement here is mu1 more than mu2. Now, if you look at the conclusion that you draw in the hypothesis testing, you say that there is sufficient evidence. That means your claim is true, or your claim is valid, that the pre is more than the post. So that means this one also state that mu1 is also more than mu2. So I think you kind of know what I'm trying to show to you guys, that this conclusion and this conclusion should be the same, right? As I mentioned early on. So please make sure you guys know this. Otherwise, it will be no good. Okay, if they're not if they're different, please if you have time in your test, especially, please recheck this in your test. Okay. And the last question we do here is part C. So we're gonna read what is part C want us to do. Do post 9064 quarters appear weight less than the pre? Okay, so this question is tricky, is because they say that post. Now we know that post is the second population and pre is the first. So if you look at this, it's asking for is post is less than pre. Okay, so its post is less than pre. But if in the world of algebra or math, when you can also change it. If you can switch it around, then if you switch it around, then your inequality will be switched. So in other words, this question is asking, is the pre-1964 quarters is weight more than post? And you can tell by looking at your conclusion that your mu1 is, your pre is weight more than your post. So again, I wouldn't come up with these kind of questions in your finals because again, they are tricky questions. They like to switch things around. On your online homework, you will see those. So make sure you understand that when you do your online homework, sometimes they are very tricky. They like to switch things around. Okay, so is the pre is weight more than the post? The answer in this case is yes. Okay, so the post weight less than pre, or in other words, pre weight more than the post. This is just they play on words. Okay, they like to do that. I just be careful with that. And then the question say, if so, why aren't vending machines affected very much by the difference? So the question is asking, well, if your pre and post quarters are weight one but not the same, right? They weight more, right? Then why vending machines still able to take these two the quarters, right? Because let's say you go to a vending machine and they only take, and let's say it's $1.50 and you got 6 quarters and 1 quarter is rejected. Guess what? You weren't able to buy that sold out whatever you try to purchase in a vending machine. But why they can still take this? So the vending machine not affected by the weight, by the weight difference, because the difference is not significant. What do we mean by the difference is not significant in this case? We can tell by looking at the confidence interval. So if you look at the confidence interval that is done in question B here, it's only the difference between the 2 quarters, the pre and the post quarters here, is around 0.5 gram. So what I mean here, class, is if you take a quarter, pre and post, and if you measure them, okay, you measure the pre and the post, and then you find the difference between the pre and the post, you notice that the difference is around 0.5 gram. And do you guys know how heavy is a 0.5 gram is? 0.5 gram is, if you have a long hair, then maybe one of your long hair for girls. For guys, if you have short hair, depends on how short, maybe 2 or 3 of your, I'm talking about 2, 3 strain of your hair, I'm not talking about a bunch, okay? So that's how heavy is a 0.5 gram is. So so that's why your vending machine can still accept this because the difference here is not too much. That means the difference is not it's not significant enough. Okay. 0.5 grams difference is not a lot to tell the difference. Okay, so that's the reason why that your quarters still work in your pre and post quarters still work in a vending machine because of this case. Okay, so this is the end of today's class. So your homework in this case will be due on next Wednesday. So back to your those who came in late, you do have 4 homework due on next Wednesday, July 24. So I will say start working on it. Okay, so you don't have a lot of homework left. We got 7 homework left in the total. So I would say start working on it. And so if you have any questions with your homework, please email me. I just bring it up again how you email questions on your homework here. Any assignments that you have questions on, go to just let's say you got question 10, you don't understand how to do question 10, just go to the get more help and ask my instructor, and then and then you type in the message in here and you hit send, and then I will get an email from you, and then I will look at because once you do this, I will see what answer you get right and what answer you get wrong, instead of just email me from the college email say, hey, David, I have question number 10 on 8.2. I will say, can you email me the question? So the best way is just do it this way. That is the best way to do it. Then my email, when I go to my email, I can click on it and see what's going on. Okay, so this is how you ask questions in your homework if you need help. Okay. All right, so that is the end for today's class here. So we will be continue the class next week.